Welcome back. So now we're going to talk about interval estimate of a population mean. So we're going to create an interval estimate of a population mean. And we're going to do this in the situation where lowercase sigma is known. And if you recollect, lowercase sigma means that it is the standard deviation for a population. So we have standard deviation for a population. Right here is the lowercase sigma. So when we have the standard deviation for a population, when that's known, we're going to do an interval estimate of a population mean, and we're going to get this estimate from our sample. And so a large part of all of this is just learning the terminology and then learning the math to make that happen. And when we know the terminology, we can talk about it, we can understand when other people are talking about it, when the textbook's talking about it, when I'm talking about it, when these presentations are talking about it. So in order to develop an interval estimate, and again coming back to our definitions here, an interval estimate could also be called a confidence interval, and that's the range of values, like plus or minus 1.23 inches. And in order to develop an interval estimate of a population mean, and I highlight all this stuff just to make things stand out. So in order to develop that interval estimate of a population mean, the margin of error must be computed. And again, ask yourself, pause the video, what is the margin of error? And the margin of error is the plus or minus 1.23. So hey, here's our sample. Here's our sample statistic. It's our point estimator. And this is the sample statistic. It's the point estimator. And then we have that margin of error. So we're saying here the sample mean is this. And then when we're estimating the population mean, it's going to have that margin of error plus or minus a certain amount. In our example, 1.23 inches. And so there's the margin of error right there. And we'll have a certain confidence level or confidence coefficient. I added this one in because sometimes the textbook, these presentations, uses the phrase confidence coefficient to talk about that. And I have no idea why I lecture like this. Like I've taught my whole life, and when I teach statistics, I kind of get a little bit methodical because it's like you have to get these very things. So anyhow, we're going to develop, in order to develop an interval estimate of a population mean, the margin of error must be computed using either the population standard deviation or the sample standard deviation. So we must compute the margin of error with either the population standard deviation or the sample standard deviation. And so here we're looking at the case where we know the population standard deviation. And remember that lowercase sigma, right? That lowercase sigma is the population standard deviation. So standard deviation is rarely known exactly for a population. That's the population standard deviation is rarely known exactly, but often a good estimate can be attained based on historical data or other information. We refer to such cases as the population standard deviation known case. Okay, so that's just the definition of an interval estimate of a population mean from our sample data when we know the population standard deviation. And so here we have, more. And there is a 1 minus alpha, this little thing right here, probability that the value of a sample mean will provide a margin of error of z. And gosh, what is that called? It's not called a power. It's called, I have no idea what that's called. I can't remember. But z, and then there's a little subscript. That's what it's, subscript versus superscript. That's what I was looking for. Z subscript alpha divided by 2 sigma, and this is the sigma, the standard. This is the standard error because it has that x bar right there. And x bar is the sample mean. And so the sample mean, here's the sample and here's the mean. X bar is the sample mean versus the population mean has mu, right? But here we have sigma with x bar subscript x bar. And what that is a standard error. And what the standard error is the standard error is the standard deviation of the sample means. So we're going to get from our sample one sample mean, but there's a sampling distribution of all the different possible samples we could have done where we got different combinations of people in our sample or whatever we're sampling. And then our mean is going to vary slightly. Sometimes the mean is 6 feet from our sample, the height of people. Sometimes it's 5'6". Sometimes it's 5'8". And there's going to be a distribution, a sampling distribution of our sample of the mean, right? Depending upon what our sample group is, right? The group is, there's a word for that. I'm not remembering it right now. There's so many words to remember in statistics. And so we have our frame, and then our frame allows us to get the elements that are in our sample. Elements is what I was looking for. And based upon the elements that are in our sample, we could have a different sample mean. And so we're going to have a sampling distribution of all those possible sample means. And then this sigma, the standard deviation of the sample means, which is also known as the standard error, that's that representation right there. So we have to break out what all of this means, like what is alpha? And so alpha is the level of significance, both tails. So I'm going to come up here, and we have level of significance, and so we have confidence level, confidence coefficient, and we have confidence intervals, the range of values. So the confidence interval is the 5.8 plus or minus 1.23. So that'd be like 5.6 something to 5.9.23. And that's our confidence interval, also known as our interval estimate. And we need to figure out what is our level of significance, And so level of significance, we have our confidence level, and we also have our confidence coefficient. And alpha is the level of significance. And so here we have alpha divided by 2. And the level of significance, there's a 1 minus alpha probability that the value of a sample mean will provide a margin of error. I just have to pause the video and figure out the right way to say this. Hang on a second. All right, so the level of significance, I'm just going to copy this here and bring it down here, just add another one in. And level of significance, and there's just, it's a new domain, and that is, and we have to learn all the terminology associated with that new domain. And I searched for significance in this presentation, and so the first time we were seeing significance is on that slide we were just looking at. And so now we're going to add a definition for level of significance. And the level of significance is 1 minus the confidence level, right? And so that would be, e.g., let's put a little e.g. in here. So e.g., right? e.g., for example, that's what e.g. stands for. It would be 1 minus 95%, 0.95. 1 minus 95% would be equal to a 0.05 level of significance. 0.05 level of significance. And level of significance is also known as AKA alpha, okay? And so that's the level of significance. And so, the level of significance, alpha, is equal to 1 minus the confidence level, And so, for example, e.g., 1 minus 0.95 is equal to 0.05 level of significance. And so, a lot of terms to wrap our heads around here. And so I'm going to, download this slide here. I'm going to go to File, Download, and go just get the PNG. And then I'm going to go to chat, and I'm going to say, take a look at the slide attached. And we'll attach that slide. Upload from my computer. And I have that one twice. I don't need that one in there twice. Delete it. And I'm going to grab that one. And please explain to me the level of significance, aka, and is this also called alpha? All right, we'll see what it says. And give it a moment to run. Oh, I hope I started my recording. I did. The numbers are ticking up. You can see them right there. That's great. The alpha, yes, alpha is indeed called the level of significance in statistics. Let me explain in detail based on the slide. The level of significance is the probability that a confidence interval does not contain the true population parameter. This is going to make sense in a second. E.g., for example, the true population mean, the population parameter, for example, the true population mean. It represents the risk we are willing to take that our interval estimate will miss the true value. Alpha is split between both tails of the sampling distribution in a two-tailed test. So alpha is split between both tails in a two-tailed test. Like if you didn't, it's just like a different language. Like two-tailed, is it a dog? It has two tails, right? If you didn't there's a lot of terminology to figure out for this to make sense. But alpha is split between both tails of the sampling distribution. For example, if alpha is equal to 0.05, then 5% of the distribution lies in the outer tails, 2.5% in each tail. So let's look at that here. So here is our, and we're saying here that our level of significance, aka alpha, is 1 minus the confidence level or the confidence coefficient. So our confidence level is at 95% right here. Our alpha is 5%, and half of the alpha is right here, and half of the alpha is right here. So you split alpha in each tail. The 95% confidence level or confidence coefficient, right, is where we're hoping the population parameter, for example, the population mean, right, falls within based upon our sample estimate, our point estimate, plus or minus our margin of error, right? So we're hoping we have our sample point estimate plus or minus some margin of error, and we're saying with 95% confidence that the population parameter, for example, the population mean, is going to fall within this this interval estimate, within this interval, confidence interval, within this confidence interval or this interval estimate, 95% confidence. But we have 5%, right? There's 5% chance that it doesn't fall within here, okay? And that's called the level of significance, or alpha, all right? And we split that 5% between each tail, right? There could be 2.5% chance that it's here and 2.5% chance that it's here. By that it is here, by it I mean that the population parameter, for example, the population mean, is here or here as opposed to in here. Okay? So now, knowing that, there's a 1 minus alpha probability that the value of a sample mean will provide a margin of error of this or less. So this is how we calculate, what is this? We have z, and we have a z score, and we're finding the z score for a certain amount of data, and then we have our standard error, which is a standard deviation of our sample mean. And we'll see how to calculate it in a second, and that'll become more clear. So alpha is the level of significance. It's both tails. And 1 minus alpha is our confidence level, aka our confidence coefficient. And so confidence level, aka our confidence coefficient, is 1 minus alpha. So 1 minus 0.05, right? 1 minus 0.05 gives us 95%. And our level of significance is 1 minus the confidence level. 1 minus 0.95 gives us 0.05, which is our level of significance. And that's the level of the confidence level, or the confidence coefficient, is the middle part, the 95% here. We have 95% confidence. And then the confidence interval is the mean plus or minus some amount that contains, and we're saying that, you know, this interval will contain mu, the population parameter, the population mean. E.g., you have a certain confidence level that within a certain confidence interval on both sides of your sample mean, the population mean will be in that range. Let's keep looking at this. So here's that same text as before, right here on the left. And just so that it's there while we're looking at this, I'm just going to fade it out just a little bit, and we'll make it like that. We'll just fade it out just a little bit. And so here is here is a sample mean from one, right? We get certain elements in our sample, and we get this as our sample mean. We get other elements in a second sample, and we get this as our sample mean. We get yet other elements in our third sample, and we get this as a sample mean. Okay, here is the true population mean, and we're saying that plus or minus 3.92, right, will include all of these, sample means 95% of the time. And so, again, we could also say, based upon this sample mean, we have 95% confidence that within this interval, right, within this confidence interval or interval estimate, we have 95% confidence that the population mean will be within this. So here's our sample mean, plus or minus 3.92, and you can see that includes the population mean. 95% of the time, our sample mean with this plus or minus 3.92 making that margin of error giving us our confidence interval or interval estimate. 95% of the time it's going to contain the population parameter, which in this case is the population mean. And then here, same thing, second sample, plus or minus our margin of error, which is 3.92, it contains the population parameter, right? 95% of the time. In this case, it did also. And then here, it does not contain. So our sample mean, plus or minus the margin of error of 3.92, does not contain the population parameter, right? And so 5% of the time this doesn't happen. So that's what this is showing, the slide here. And it's showing that our standard error here, the standard deviation of the sample mean is 2. And it shows that here's our interval based upon our sample mean, the first one, plus or minus 3.2, the margin of error. And interval is based upon this. Note that this interval does not include the population mean. So the interval estimate of the population mean is going to be the sample mean plus or minus, right, this margin of error. So here's how we calculate the margin of error. And we have z sigma over and sigma subscript x. And here we have z alpha 2 sigma of the population, because this is the standard deviation is known of the population. And then we divide that by the square root of n. And so here, right, just to look at these, x bar is the sample mean, 1 minus alpha is the confidence coefficient. And the confidence coefficient, if alpha is, and alpha is defined as the level of significance, right? 1 minus the confidence level gives us our level of significance. And down here, we're saying 1 minus alpha. So 1 minus alpha is going to give us our confidence level. So if alpha is 0.05, 1 minus 0.05 is going to be 0.95, which would be our confidence level, right? So common confidence level is 95% confident. And so the confidence coefficient, or the confidence level can be calculated by 1 minus alpha, which is, and alpha is our level of significance, right? The amount of time that the population parameter is not contained within the confidence interval, okay, which is the point estimator plus or minus the margin of error. And z subscript alpha 2 is the z value providing an area of alpha divided by 2 in the upper tail of the standard normal probability distribution. This is the population standard deviation. This is the sample size. And so if you look at this, right, so let's say we want a 90% confidence level, or 95% confidence level, or 99%. If we want a 90% confidence level, 90% of the time, let's do 95%. 95% of the time, right, our sample mean will have a margin of error, and this confidence interval or interval estimate, right, will contain the population mean, right? So the sample mean, you know, as a point estimator with a margin of error giving us our interval estimate or our confidence interval, 95% of the time, this will include accurately the population mean, right? So the sample estimate will include the population parameter that we're trying to determine from our sample. And so here, 95%, and then 5%, that's the 95% part. 5% of the time, it will not. So the 5% is 2.5 here and 2.5 here, and this is the 95%, right? And all this has to be 100%, so 1. And then if we look at alpha divided by 2 just for one tail, that's 0.025. And so if you come here and you look at the z table, because data to the left, you know, the data to the left, if this is 0.025, the data to the left is, if this is 2.5%, the data from here over to the left is 97.5%, 97.5%, right? This is 2.5%. From here over is 97.5%. And so 97.5% is the data to the left. If we go to our z table and we look for 97.5%, it's right here. Okay, and then the z-score associated with that is 1.9, and it is 1.96. 97.5% is 1.96. That's our z-score. That's the z subscript alpha divided by 2. The z-score is 1.96. If you remember what the z is like a measure of how far is some data point from the mean in standard deviations, right? So it's like a measure of how many standard deviations is this point from the mean. That's what z is. How many standard deviations is this point from the mean? I'm going to just close that. And so this point is 1.96 standard deviations from the mean. And when we have that, we could come down here and we could say because 90% of all the intervals constructed use x bar plus or minus 1.645. 1.645 is the 90% confidence level, that z-score. So if we go here, 90% confidence level, 90% confidence level means that we have 95% of the data to the left. Okay, because our alpha is 10%. This is 90%. Our alpha is 10%, which means we have 5% here and 5% here. So we have 95% from here over, right? This is 5% here. This is 95% from here over. And so 95% would be right between these two, right there. And it'd be 1.645, 1.645, which is what that is. 90% is 1.645. And so because 90% of all intervals constructed using the mean plus or minus 1.645, and then we multiply it by the standard error, which is the standard deviations of our sample mean. And 1.645 is how many standard deviations. So we're saying we're going to have our sample mean plus or minus this many standard deviations. And here is the value of those standard deviations. So 1.645 of this right here, of the standard deviations, the standard error. And then that tells us our confidence interval, right? That tells us our confidence interval. So confidence interval, aka interval estimate. And so we will contain, we have 9%, because 9% of all intervals constructed using this will contain the population mean, we say we are 90% confident that the interval, this plus that plus or minus that, includes the population mean mu. We say that this interval has been established at the 90% confidence level, right? The value 0.9 is referred to as the confidence coefficient. The confidence coefficient, okay? And, you know, I could say more about that, but what about this, I guess the last thing I'll say is what about this other, like 5%, if we're dealing with 90% and 5% here and 5% here, alpha of 10%? Well, when you do it from here to there, you get the value, which is the value of all the data from here to the left. So what about this part? Well, what you're looking at is you're looking for this point right here, and that point right there at 95% confidence, right, is 1.645. 1.645. At 90% confidence, or an alpha of 10%, and alpha divided by 2 is 5%, right? So here, this 5% and then 95% of the data this way, you get 1.645. 5% is in the upper alpha tail, and then 95% is to the left of that. You get 1.645. And so that number, that many standard deviations from the mean, right, from the mean to here, is like where that point is. Well, you know that's 1.645 standard deviations from the sample mean, okay? Or from the population mean. And then because this is symmetric, you could just say it's also 1.645 this way, right? And so you're really calculating from here to there and from here to there. But then you could also apply that to your sample, because you could think about it that way. And so wherever this falls, if it's within this range, it's going to reach that far to this side or reach this far to that side. I don't know if that makes sense, but so that is like, you know, how you calculate, that is how you calculate the confidence interval. And let me just pause this for a second and collect my thoughts to try to make this as clear as possible. All right, I'm back. Okay, so the next thing, it's a lot, I know, but it becomes clear when you do the examples. I don't know, maybe we should save the example for the next video, but let's do it. Let's break it up. So in the next video, we're going to take a look at this example and see how to apply it. See you in the next video.